Okay. So, whatever we have discussed here, same thing has been made for you, right. So, I have not further explaining this, just I have told you. Now consider this example 7. So, for the circuit of figure this one 2.18a, you have to find out voltages V1 and V2. So, this is actually the circuit is given, this is a 40 volt source, 4 ohm resistor and this is a 6 ohm resistor, these are the polarity is given. Now, what we are doing is, look, we are your just hold on, what we are doing it that this from this circuit we are making, say this is your this is the circuit, right. So, question is that here we are taking a current, it is a simple series circuit because 4 ohm then 6 ohm then 40 volt all are in series. So, same current will flow through this circuit. So, we have taken a current flowing like this is clockwise, that means this I is flowing like this and returning to the source again. This I this is I, but for your understanding here it says I moving in the line here also and here also returning, right. So, question is that resistor actually we will see here it is marked plus minus the 4 ohm, here it is minus plus and then Ohm's law and KVL or what you call will apply, right. So, KCL here KVL will apply, Ohm's law along with KVL. So, now let me first clean this one, right. So, if you from Ohm's law, if you come here this one V1 is equal to 4 into I, that is your this is 4 into I, but in this that is current entering the positive terminal 4 into I. So, but here the way we have taken the polarity that current entering into the minus terminal, later we will see that both the resistor actually absorb power, right. Passive element always absorb power, but as the terminal we have polarity we have taken, this is minus and this is plus, current entering into the minus terminal. So, V2 will be minus 6 into I. So, V2 will be minus 6 into I, right. So, when it is entering plus terminal, earlier we have discussed V1 will be 4 into I and here entering the minus terminal. So, V2 will be minus 6 into I, right. So, applying KVL around the loop. Now, you apply KVL in this loop. So, when you moving it, look, I am moving clockwise clockwise. So, again for your understanding, initially I am showing everything. Suppose I am moving clockwise, that means I am moving like this clockwise, right. So, plus terminal this thing or what you call, if you move clockwise, so first it is encountering minus terminal of the 40 volt source, that means it will be your, I am writing here, later we will come to that, it will be minus 40, right. Then this when you are moving clockwise, it is encountering plus terminal first. So, it will be plus V1, then now when you are moving like this, it is coming here. So, it is encountering minus terminal first. So, minus V2 is equal to 0, right. So, minus 40 plus V1 minus V2 is equal to 0. Now, V1 is equal to 4I we have seen earlier. So, that will show you later. So, 40 plus V1 is equal to 4I, because V1 and this V2 is equal to, because entering into the minus terminal we have seen. So, it is minus V2 is equal to minus 6I is equal to 0, right. That means, if you solve this circuit, actually 4I minus plus 10I, actually 10I is equal to 40, that means I is equal to 4 ampere, right. So, let me clean it, this I have done it later, but for your understanding I showed this one. So, let me clean it, right. So, this is actually I is equal to 4 ampere, that is minus 40 plus V1 minus V2, whatever just now I wrote for you. So, in this case V1 is equal to, you put 4I and V2 is equal to minus 6I. Equation numbers are all given 1, 2, right. So, if you put it, it will be 10I is equal to 40 or I is equal to 4 ampere. That means, if you put I is equal to in equation 1, it will give V1 is equal to 16 volt, because V1 is equal to 4I. So, 4 into I is equal to 4 ampere and V2 is equal to minus 6 into I is equal to 4, that is V2 is equal to minus 24 volt, because if V2 is equal to minus 6I, right. V2 is equal to minus 24 volt means here polarity is V2 minus plus, if it is minus 24 means actually minus will be reversed, it is actually plus and then it will become minus, understandable to you, right. So, next one we will take a dependent source. Slowly and slowly we will enter into the little bit improved circuit problem. That means your what we call degree of softness slowly and slowly will decrease, right, and hardness will slowly and slowly will increase. So, for the circuit of figure, this thing is determine, you have to determine V 0 and your I 0. Now, this is a circuit, we are taking clockwise direction. I told you anti-clockwise also you can take, absolutely no problem, right. So, question is that there is a your 6 volt source here, here also one 2 volt source, their polarities are marked, and this is a 2 ohm resistance, and this is a dependent voltage source 2 V 0, and this V 0 is here, right. This V 0 actually across 3 ohm your resistor. So, and current is entering into the minus terminal. Look, this I we have taken clockwise direction. So, current entering plus terminal, here also entering the plus terminal, here current entering the minus terminal, and here current entering into the minus terminal. So, right. So, we have to find out V 0 and I, that means this V 0 and the current I. So, now you have to first apply the KVL. If you apply KVL, look, we are moving clockwise, right. Again for you I am making it, after 2-3 problems I will not make it again and again. Now, when by that time your this concept will be clear to you. So, I am moving this thing clockwise. So, this one this clockwise I am moving, clockwise I am moving, clockwise I am moving, and clockwise I am moving. So, as soon as I move clockwise, that minus 6 will come first, right, because it is encountered negative terminal. So, it will be minus 6. Then here it is your what you call plus your voltage I have not marked. So, it is plus terminal it is entering, right. It will be actually voltage drop will be according to Ohm's law, that is your IR. So, it will be 2 into I. So, it will plus terminal it is encountering, it is 2 I, right. Then again it is encountering plus terminal. So, 2 V 0. So, it will be plus 2 V 0, right. Then here it is encountering minus terminal. So, minus 2, and here it is entering minus your what you call terminal. So, it is minus V 0 is equal to 0, right. So, this is your KVL. So, that means minus 6 plus 2 into I, because V is equal to IR, R is equal to 2, encountering plus terminal. So, 2 I, here also plus terminal. So, 2 V 0, here encountering minus terminal. So, minus 2 because it is a voltage source, here also minus terminal, voltage across this 3 ohm is given V 0. So, it will be minus V 0, and V 0 will be minus 3 into I, that we will see later, right. So, this is equation is equal to 0. So, let me clean it, right. So, just hold on. So, if we write this equation, whatever I have written here, minus 6 plus 2 I plus 2 V 0 minus 2 minus V 0 is equal to 0, or your minus 6 and minus 2. So, minus 8 plus 2 I plus V 0 2 V 0 minus V 0 is equal to 0, right. This is equation 1. So, now applying Ohm's law to the 6 ohm resistor, because it is I just told you it will be V 0 is equal to minus 3 into I, because it is this current entering here is a minus terminal. So, V 0 is equal to minus 3 into I. So, it is V 0 is equal to minus 3 into I. So, this V 0 is equal to minus 3 into I, you substitute equation 2, you substitute here, you substitute in equation 1, you substitute here, right. If you do so, it will be minus 8 plus 2 I minus 3 I is equal to 0. That means minus 8 minus I is equal to 0, I is equal to minus 8 ampere. So, when I is equal to minus 8 ampere means actually current, actually we have taken clockwise direction, actually current flowing in other way. So, that means when it is I is equal to, it is coming minus 8 ampere. If it is minus 8 means that means current actually is flowing like this, it is flowing like this, this is 8 ampere, the current is flowing like this, right, because direction will be reverse, because it has become minus, right. So, I should clean it first. So, it is understandable to you. So, here we got I is equal to minus, and V 0 is equal to minus 3 into I, because we said that current entering the minus terminal. So, V 0 is equal to minus 3 I. So, V 0 is equal to minus 3 into I is equal to minus 8. So, V 0 is equal to your 24 volt, right. So, and if you look into that, V 0 is equal to 24 volt, that is plus, that means if you look into that once again, that current actually flowing in this direction. Just now I showed, because it is minus means the current is flowing in the your anticlockwise direction. So, and V 0 is equal to your, we got 24 volt, right. So, if you look into that passive element, no, resistors are passive element, this is also resistor passive element. So, current enters is absorb power. So, you will find current enters into the positive terminal, right, or negative terminal, right. So, whatever it is, now if you, for this circuit, if you now try to make it the power balance equation, that which source is absorbing power and which source is supplying power, you can get the power balance also. So, anyway, then let me clean it, right. So, that is up to you. So, this now this is so what I suggest for this problem, that power balance equation you will obtain and see that your what you call that your power supplied is equal to power absorbed, right. So, this is your what you call another problem. In this case, and in this case what will happen, that your that one more thing let me tell you, in this case that your V 0, one more thing I should tell you, then it will be very easy for you. One more thing I should mention it, because you are beginners, I assume most of you are beginners. So, V, this voltage here, that V, this voltage, say across this voltage is say V volt. So, V is equal to actually 2I, V is equal to 2I. That means, actually original I got minus 8, that is 2 into minus 8, that is minus 16 volt, right, minus 16 volt. As soon as you get V is equal to minus 16 volt, means current is flowing in this direction. So, automatically that as a minus, this terminal will be, I am not marking here or marking for you, this terminal will be plus, this terminal will be minus, and current is 8 ampere current is flowing like this. So, actually if you take V is equal to your 2I, I is equal to minus 8. So, minus 16 volt, the polarity will be reversed. So, actual polarity, this is plus, this is minus, right, and look, this current entering, it is a resistor, no, it will absorb power. So, current entering into the positive terminal, and here also moving that current entering the positive terminal, right. So, concept has to be cleared, I mean right from the beginning you should make our concept clear, such that absolutely there will be no problem. Same philosophy will follow for AC circuit, instantaneous polarity. So, if you understand the DC circuit one, then you will find AC circuit is as simple as anything, right. So, let me clean it, right. So, power I have told everything. So, you find out power absorbed or power supplied from the point of view of your assignment of this course. Now, another one, this time we have taken, you have to find out I 0 and V 0 in the circuit of figure 2. This is a series parallel, three elements are in parallel, right, all three elements are in parallel. So, one current source is there, this is a dependent current source, and this is the current I 0, and this is your voltage V 0, and this is a 3 ampere current source. You have to find out I 0 and V 0. So, what you do, this is one node, right, at this node you apply your what you call KCL. So, if you apply KCL, look how you will do it, I am making it for you, right. So, this is 3 ampere current, the 3 ampere current actually entering into this node, this is 3 ampere current entering into the node, and this is your node A, and this is 0.5 I 0. So, this current entering also 0.5 I 0, and I 0, this current is leaving the node, I 0 current is leaving the node. Therefore, if you apply KCL at your what you call at node A, then your I 0, that is the outgoing current, I 0 is outgoing current, is equal to 2 currents are incoming. So, outgoing current, actually in general, that sum of the incoming current is equal to sum of the outgoing current. Here only one outgoing current I 0. So, I 0 is equal to actually it is 3 plus this 0.5 I 0, right. So, because from that you can find out your what you call I 0, that means 0.5 I 0 is equal to 3, because I 0 minus 0.5 I 0. So, that means I 0 is equal to your 6 ampere. Got it? I think you have got it, right. So, let me clean it. right. So, that I have done it here for you, sorry, right. So, if you see that I is equal to 3, so I 0 is equal to 6 ampere. Now, V 0 is equal to 4 into I 0. So, this is this current is entering the positive terminal. So, Ohm's law will tell that V 0 is equal to 4 into I 0. So, I 0 you got 6 ampere. So, V 0 will be 4 into 6. So, 24 volt. So, V 0 is equal to 24 volt. Here also you find out power absorbed or power supplied. This is not done. All these things if I do, it will be too lengthy. It is an exercise for you. For every case you find out power absorbed or power supplied by the your electrical elements, right. So, next one, now next one will see, now this is a series parallel circuit. This circuit is a circuit is given, right. You have to find out I 1 and V 0. I 1 is this current, I 1 is this current, and V 0 is this voltage. All the things are given. This is a 10 ampere current source. A 10 ampere, here you have a 10 volt voltage source. Here you have a 10 ampere current source. You have a 5 ohm resistor here, 5 ohm resistor here, and this is a 10 ohm resistor across which voltage V 0. This is loop 1, right. Now, question is that your this current is I 1, this branch current, let me mark it for you. So, this branch current is this is your I 1, this is marked here, right, this is I 1, and this 10 ampere current is a current source. So, this 10 ampere current also entering here. So, this 10 ampere is also marked, this 10 ampere, and outgoing current, if I take here I am writing I 1 plus 10. Suppose if outgoing current that is from, this is a node, this is a node, right. Suppose it is if it is a node A. So, if you apply, then this current, say it is I, this current is I, right, then it is outgoing current I is equal to incoming current, that is your I 1 plus your plus 10, right. So, I is equal to that, instead of writing I, directly we are writing this current is I 1 plus 10 flowing through this branch, right. So, let me clean it, right. So, hope this thing you have understood, right. So, here also now you have to apply KVL in loop 1. So, this loop 1 will apply and will move clockwise, we move clockwise. So, if we move clockwise, hold on again, right. So, if we move clockwise, that means we will move like this, we will move like this, we will move like this, we will move like this clockwise, right. If we move clockwise, then accordingly first what, that minus 10 volt we are encountering in this, right, minus 10 volt. So, we will write minus 10. Then second thing is that we have not marked here plus minus. So, if I mark, this is my plus and this is my this, even if it is not given, you have to mark it, right, you have to mark it. And if you take clockwise direction, suppose in this case resistor is a passive element and it absorbs power. So, current entering into the positive terminal. So, here current entering the positive terminal, and this current flowing through this branch is I 1, that means according to Ohm's law it will be 5 into I 1. So, minus 10 plus 5 into I 1. Now, you are moving to this. So, it will be actually 10 ohm plus this 10 ohm resistance into your into I 1 plus 10, right. Or this equation also can be written, I mean if you want, that it will be your minus 10 plus your 5 I 1 plus V 0, and V 0 is equal to actually, and V 0 actually it is current entering into this I 1 plus 10 entering the positive terminal. So, it will be 10 into I 1 plus 10, this is your I 1, this is I 1 plus 10, right. So, directly I am writing, and this is equal to 0, right. So, when I am writing many times equation, by chance right hand side, if I by chance miss 0, so you forgive me. So, hopefully I have not missed till now, but there is every possibility, right. So, this is your so I am, let me clear it, right. So, hope this thing is your clear to you, right, sorry, clear to you. So, thus I am writing minus 10 plus 5 I 1 plus 10 into I 1 plus 10. Now, you simplify is equal to 0. Now, you simplify. So, so what you do, both side actually divided by 5. So, it is minus 2 plus I 1 plus 2 I 1 plus 20. I mean this equation both side divided by your 5. Therefore, I1 we get minus 6 ampere. If you get I1 is equal to minus 6 ampere means the current actually in this branch flowing in other direction. So, whenever we are taking that I1 is equal to minus 6 means the current actually 6 ampere current actually flowing in this direction, right. Does not matter from as far as your laws are concerned, put accordingly, you will get all the result. So, let me clear it. Right. So, now V 0 is equal to, just I showed you previously, the 10 into I 1 plus 10. So, 10 into I 1 is minus 6. So, it is 10 minus 6, that is your 40 volt. So, V 0 is equal to 40 volt. Now, I 1 is equal to minus 6 ampere. This means that 6 ampere current is flowing into the 10 volt voltage source. I told you that as I 1 is minus 6 means it is your what you call, it is flowing to your in this direction, that entering in it is minus 6 means it is this direction, right. That means it is this direction current is flowing this direction, then we entering into the voltage, that is plus terminal. That means this 10 volt source actually is absorbing power, because when it is leaving the plus terminal it is supplied, when it is entering the plus terminal it is your power absorbed. So, let me clean it. Right. So, now current through 10 ohm resistor is, this is also given 4 ampere. So, current through 10 ohm resistor, this is also told you. So, this is I told you that voltage source is absorbing power. So, here also you will find out power absorbed or power supplied by that each electrical element, right. Resistor anyway absorb power. So, this is also absorbing power, then which is supplying power. So, accordingly you have to just find it out, right, what, and see that power balance equation is matching. Now, another one. So, this is find the current and voltage in the circuit shown in figure 2. Here you have to find the current and voltage. So, one current is I1 is there, this is I2 is there in this branch, right, and I3 is there, right. So, this voltage is marked here, all polarities are marked here. This is V1, this is V2 and this is V3. V1 is voltage across 16 ohm resistance, V2 is across 6 ohm and V3 is across 12 ohm resistor, right. And there are two loops, I have taken clockwise, you can take there are two loops, one loop is here, one loop is here, right. And you have to find out your what you call voltages, currents and voltages in this circuit, the way it is marked. Then you have to find out I1, I2, I3 and then V1, V2, V3, only one voltage source is there. So, now you have to apply KCL at node point, that is at node P, right. This is your node, this is your node P, right, this is your node P, just hold on, this is your node P. So, here if you apply that outgoing, this I1 is entering at point P and I2, I3 leaving point P, right. That means I1 is equal to your I2 plus I3, right, that is KCL. So, let me clean it. Right. So, now that is your I1 is equal to I. Now, applying KVL to loop 1. If you apply KVL to loop 1, several things we have told. So, if you move like this, it is encountering minus terminal plus, because clockwise we are moving. So, it is minus 60, then it is plus V1, it is encountering moving clockwise. So, encountering plus terminal first. I am not showing again and again by your blue ink. So, it is understandable now. So, it is if you move clockwise, it is encountering plus terminal now. So, that is why it is plus V1, and here also when you move in this loop, it is your what you call plus terminal it is encountering. So, plus V2 is equal to 0, right, is equal to 0. This is your loop 1, and if you apply your KVL in loop 2, we are moving in the your what you call in the clockwise direction. So, encountering plus terminal first. So, it is your plus V3, then it is when you are moving like this clockwise encountering minus terminal first. So, minus V2 is equal to 0. So, minus V2 plus V3 is equal to 0. That means, if you move clockwise, first I am writing it is encountering minus terminal minus V2 and then encountering plus terminal plus V3. So, minus V2 plus V3, same thing is 0. So, V3 is equal to V2, right, and by Ohm's law, this current is your clockwise we are taking this current actually I1, it is entering into the positive terminal. So, V1 is equal to 16 I1, because this current flowing through this branch, that means it is entering into the positive terminal. So, V1 will be equal to your 16 into I1. Similarly, if you take V2, the I2 actually entering into the positive terminal. So, V2 will be 6 I2. So, your V2 will be 6 I2, here it is V2 is equal to 6 I2, and here I3 actually entering into the positive terminal. So, V3 will be 12 I3. So, V3 actually is equal to 12 I3. So, V1, V2, V3 all you have got in terms of it is I1, it is I2, I3. Now, from equation 3, that means from equation 3 V3 is equal to V2, that means V3 is equal to 12 I3 and V2 is equal to 6 I2, that means we have got a relation I2 is equal to 2 I3. I mean the way you solve linear equation, this way you have to make it. So, from equation 1 and 4 we obtain equation 1 and 5, equation 1 and 5. So, come to equation 1, this is equation 1 and equation 5 is I2 is equal to 2 I3. So, put here I2 is equal to 2 I3. So, if you do so, you will get I1 is equal to I2 plus I3, I2 is equal to 2 I3. So, I1 is equal to 3 I3, right. So, from equation 4, that means from this equation, from equation 4, right, substituting V1 is equal to 16 I1 and V2 is equal to 6 I2 into equation 2, you will get, just substitute, you will get minus 60 plus 16 I1 plus 6 I2 is equal to 0, or divided by 2 both sides. So, sorry, minus 30 plus 8 I1 plus 3 I2 is equal to 0. Now, you substituting I1 is equal to 3 I3 and I2 is equal to 2 I3 into equation 7. All this I1 3 is equal to 3 I3, I2 2 I3 all you have got. Just you have to manipulate mathematically and you have to put one after another. If you put, so not showing it you, it is understandable, right, it is understandable. If you do so, it will be minus 30 plus 8 into 3 I3 plus 3 into 2 I3 is equal to 0, or 24 I3 plus 6 I3 is equal to 30, or I3 is equal to 1 ampere, and we have seen we have got this relation I2 is equal to 2 I3. So, I2 is equal to 2 ampere and I1 is equal to 3 I3, I3 is equal to 1 ampere. So, I1 is equal to 3 ampere. Now, V1 is equal to 16 into I1. So, 16 into 3, so 48 volt. V2 is equal to 6 IT, so 6 into I2, so 6 into 2, because I2 is equal to 2 ampere, so 12 volt, and V3 is equal to 12 I3 is equal to 12 into 1 is equal to 12 volt, right. So, this here easily you can solve it, only you have to judiciously see that how quickly you can solve it by putting equation one to another, right. And here that find the voltages V0 in the circuit shown in figure 2.23, also find V1 and V2. So, this is the circuit, this is your 4 ampere current source, this is your one 10 ohm resistor is there, this is one voltage source one resistor is there 2 ohm, across which voltage is V0, here across voltage is V2, and then here voltage is your V1 and it is 2.5, this is a current source 5 I1 dependent current source, right, this is 5 I1 and I1 is flowing here. So, this is 4 ampere current source, through this branch current is flowing I2, this is I1 current flowing through I3, right. So, what you do this thing, you have to find out voltage V0 in the circuit shown in figure, also find V1 and V2, that means you have to find out V0 as well as V1 as well as V2, right. So, if you apply KCL at node 1, this is node 1 is marked, node 2 is marked, you can see the diagram node 1, you apply KCL here. If you apply KCL, I1 plus I2 is equal to 4, right, because this this is 4 ampere current source. So, this current 4 ampere is entering here, right, and this is I2 is leaving, I1 is also leaving. So, incoming current I1 4 is equal to I1 plus I2. So, I1 plus I2 is equal to 4. So, let me clean this one, clean this one, right. So, this is your applying KCL at node 2, you apply KCL here also, current I1 is entering at node 2, I3 is leaving and 5 I1 also, this is a dependent current source, it is also leaving, right. So, this is actually just a minute, this is actually your this 5 I1, right, this is 5 I1, right. So, so I1 is equal to 5 I1 plus I3, right. So, let me clean it first. right. So, your I3 plus 5 I1 is equal to your I1. So, this is I3 plus 5 I1, both are outgoing current I told is equal to I1. So, I1 is equal to your I3 plus 5 I1, or I3 is equal to minus 4 I1. This is equation 2. Now, apply KVL in loop 1. If you apply KVL in loop 1, this loop, so it is encountering your the way I am writing here, right. So, I am writing from V0. So, encountering plus terminals first, plus V0 plus again encountering clockwise plus terminals first, plus V1, and here it is encountering minus, this is minus sign, clockwise we are moving. So, minus V2 is equal to 0. So, it is V0 plus V1 minus V2 is equal to 0. So, put V0 is equal to 2 into I1, because this is my V0 and this is your this current I1 is entering the positive terminal, Ohm's law. So, V0 is equal to 2 into I1. So, here it is V0 is equal to 2 into I1. Now, V1 is here, the current your I3 actually entering into the positive terminal. So, V1 will be 2 plus 2.5 I3. So, here V1 is 2.5 I3. Now, minus V2 is equal to your 10 I2. This is your V2 and this I2 current entering into the positive terminal, Ohm's law. So, V2 is equal to, it will be plus 10 I2, that is why it is 10 I2. So, minus 10 I2 is equal to 0. Now, from equation 3 and 1 you will get, just manipulate, right. Equation 1 it is given, equation your 3 it is there. So, from equation 3 and 1 just substitute, that is all. If you substitute and simplify, you will get I1 is equal to 20 ampere, right. So, this is now understandable to you. Now, nothing there, absolutely there should not be any problem now, right. Just equation your from equation 3, 2 and 1 we get, from 1 and 2 whatever is there, from 1 this relationship, from 2 this relationship, right, and you substitute in 3, right, all these things you put here. So, you will get, after solving you will get I1 is equal to 20 ampere. So, V0 is equal to 2 into I1, because this is your V0 is equal to 2 into I1 plus 2 I1. So, V0 is equal to your 2 into 20, 40 volt. Now, V1 is equal to 2.5 I3. So, 2.5 and I3 is equal to your what you call minus 4 this thing, I3 is equal to minus 4 I1 and I1 is equal to 20. So, that means your 2.5 minus 4 into 20. So, it is minus 200 volt, right, and V2 is equal to 10 I2. So, 10 into your I2 is equal to, if you see this is your what you call I2 is equal to 4 minus I1, right. Just writing one thing for you here, I2 is equal to your 4 minus I1 and I1 we got 20. So, it is minus 20 is equal to minus 16 ampere, right. So, I2 is equal to 4 minus 1. So, if just let me clean it, right. So, little bit you do it, this is simple thing. So, here if you see that 10 into 4 minus 20. So, minus 16 into 10 minus 160 watt, sorry volt, sorry it is volt. So, V2 is equal to minus 160 volt. So, with this whatever little bit we have studied, Kirchhoff's first law and second law and all these numericals, you are with and without considering the your dependent voltage and current source, and all the your what you call that your polarity convention and how to apply KCL and KVL, and that plus minus how we will take voltage drop or voltage rise, all these things, and in along with that Ohm's law and your KCL and KVL, and we will be back again. Thank you.